All right, Trig, welcome to your Monday, May 12th video. All right, so first off, you do not have this packet, and that's all right. You're gonna write things down in a notebook or on a piece of paper, because you might turn something in at the end of the hour. Anyway, so we have hooked on conics, huh? That's fun. This is kind of our chapter 10. We're gonna go through this real quick here. So introduction to conics. Conic section literally means a section of a cone. All right, so you got a cone like this. Imagine a double napped cone as seen below being sliced by a plane. If you slice it with a horizontal plane, bam, you have a circle. Cool. All right, followed by tilting the plane ever so slightly produces an ellipse. Nice. If the plane cuts parallel to the cone, we get a parabola. Nice. And if we slice the cone with a vertical plane, we get a hyperbola. Those are the four conic sections. For wonderful animation, bam, right there. Look at that. Okay, so here's what we're talking about. So circles, all right? So first off, look at this. We got that right there. From the picture, we can see that the point XY is on the circle if and only if its distance to HK, which is the center, is R. We express this relationship algebraically using the distance formula, all right, which then can be written like this. All right, that's the equation of the circle with center HK. We know that. All right, we've talked about that in the past a little bit, especially in college algebra. At the end of the year, we did a little conic section review at the end of the year, just like we're doing now. All right, so write the standard equation of a circle with center -3, -2, 3, and radius 5. X minus the x value plus y minus the y value is equal to the radius squared. All right, this next one, how do I graph? We're gonna kind of not do the graphing. Well, we'll see. Hold on to that thought. -2, 1. -2, 1 is the center. The radius is 2. All right, sometimes the ACT asks easier circle questions like that. All right, then lastly, what is going to be new for us? So write an equation of the circle in standard form. What's going to be new to us is kind of completing the square twice like this. You see that? And I'm going to explain it in some examples we are going to do together here in 1 minute. So if I gave you, if you're given this equation, you'd want to put the x's together, you'd want to put the y's together, you want to move the constant over to the other side, then you would say, because you can only complete the square if you have a single x squared or a single y squared, which you don't. So you factor out the 3 that both of those have in common. Here you have to factor out the 3 that's attached to y. And like, that's not great, because when you complete the square, you take half of this and then square it. All right, it's easy to take half of -2, which is -1, and square it to get 1. All right. And then, again, we're gonna do an example like this in a second, but if I take half of -2 and square it, I get 1. I'm not adding, though, just 1 to the left. I'm actually adding 3 times 1. So I'm adding 3 to the left, which means I need to add 3 to the right. If I take half of 4/3, I get 4/6, which is 2/3. If I square 2/3, I get 4/9. I'm not just adding 4/9 to the left, though. I'm adding 3 times 4/9. This adds together to get 20. 5/3, and then remember the equation of circle is just x minus h squared, y minus k squared. So these 3's on the outside, I have to divide everything by 3. Then I could say I have a circle with center 1, -2/3, and a radius of 5/3. I take the square root. It's gonna be important for us to know how to complete the square in calculus. All right, so again, you don't have this packet, which is fine, but we have a lot of nice exercises. So that is what we're gonna do here. All right, page 5 in this. Write this down as an example. We're gonna write this circle with a center of -3, 7/13, and a radius of 1/2. We're gonna write that in standard form. So again, this is HK. It's going to be x minus a negative 3 squared plus y minus 7 over 13 squared equals the radius 1/2 squared. All right, to subtract negatives to add. And what's 1/2 squared? It is 1/4. Those questions, even if h and k are odd, shouldn't be that difficult. All right, this isn't a pre-calculus text, folks, so it's going to get a little interesting. What happens if I have a center pi, comma, e to the second? And I have a radius of the cubed root of 91, or 91 to the 1/3 power. So the center, oh my goodness, I made a mistake. Wrote the wrong thing down. The center is x minus pi, clearly pi, x minus pi squared plus y minus e squared, e squared is equal to, yeah, so this is h, this is k. That means this goes with x, this goes with y. All right, e for Euler's constant. Anyway, the cubed root of 91 is 91 to the 1/3. So what do I have to do with that radius? I have to square it. So it's going to be now 91 to the 2/3 power, which I think is a fine answer for us right now. All right, what we really want to do well is the following. Find the center and the radius of blank. So x squared minus 4x plus y squared plus 10y equals negative 25. So they already moved the constant over for us. So what we have to do is complete the square twice. I asked myself, what's half of negative 4? Half of negative 4 is a negative 2. What's negative 2 squared? Plus 4. Now, if I added 4 to the left side, I have to add 4 to the right side. All right, great. Now look here, because again, I don't have to factor anything out because it's a single x squared and it's a single y squared. Then I take half of 10. What's half of 10? It's 5. What's 5 squared? It's 25. So I add 25 to the left, which means I need to add 25 to the right. What is negative 25 plus 4 plus 25? It's 4. All right. Then what multiplies to 4 and adds to a negative 4 and negative 2 twice? It's always half the middle term. Okay, what's half the middle term? 5. 25, what multiplies to 25 and adds to 10? 5. Y plus 5, all of it squared. The center is 2, negative 5. The radius is 2. All right, take the square root of this. Center is 2, negative 5, and the radius is 2. This is the equation in standard form, center, radius. All right. Then we have here possibly a few more of those. Again, pause this at any time if you need to. It might be about a 20-minute video or so. Might be a little quicker. First of 3 videos that I'm prepping before I go see Mickey Mouse. All right, x squared plus y squared plus 8x minus 10y minus 1 equals 0. So first off, you're going to move the negative 1 over. Then I need to get the y's together, and then I need to put the x's together. So I'm going to say x squared plus 8x, y squared minus 10y. Okay. Completing the square time. I'm going to take half of 8x. Half of 8x is 4x, or half of 8, sorry, the middle term, 8 there. Look at that number. If I take half of 8, I get 4. And what's 4 squared? 16. So if I add 16 to the left, I need to add 16 to the right. Then right here, I take half of negative 10, which is a negative 5. If I square it, I get a positive 25, which means I have to add 25 to the other side, okay, which is 42. Multiplies to 16, adds to 8, it's 4 twice. It's also half the middle term. Well, multiplies to 25 and adds to negative 10. It's negative 5 twice. What's half of negative 10? Negative 5. So x plus 4 squared plus y minus 5 squared is equal to 42. The center is a negative 4, positive 5, and the radius, if r squared is 42, r is the square root of 42, which will not break down. Okay, and then finally, with this last type of example, we have the following. Number 11. Okay, so you have 4x squared plus 4y squared minus 24 plus 16 equals 0. Honestly, you would be wise. You could divide everything by 4 right away. You could do that, but let's practice this just in case you couldn't divide everything by the 4 that they both share. Okay, so what I did, oh man, I don't have any other x terms, so I just have 4x squared, right? 4x squared plus like 0x. All right, then I have y squared minus 24y. Okay. All right, anyway, x squared, I have 0x because, you know, this is one way to do it. What's half of 0? 0. What's 0 squared? 0. All right, and then honestly, we're going to fix this here a bit at the end. Okay, then I have to factor out the 4 that they have in common. Put the 4 on the outside. Leaves me with y squared minus 6y because negative 24 divided by 4 is a negative 6. I take half of negative 6, which is negative 3, and I square it. I get 9. Now again, 9 times 4. It's going to give me a 36 on the other side. Plus 0 plus 36 minus 16 is 20. Is 20. And the square root of, I don't know what I was thinking. The square root of 20 is, yeah, anyway, oopsie. Let's continue. So, oh, I know why, because I divided everything by 4. I'm sorry. So you have 4 times x plus 0 squared plus 4 times y minus 3 squared is equal to 20. Equation of a circle, it's just got to be x minus h squared, y minus k squared. There can't be a number coefficient on the outside. I got to divide everything by 4, which is why I should have 5 there. You wouldn't say x plus 0. You would just say, you would say the following. So yes, some of you are like, couldn't I have just divided by 4 from the get-go? And that is a yes. All right, then you have x squared plus y squared minus 6y. Half the middle term is negative 3. If you square it, you get 9 equals negative 4. You're going to move this over. Then you have to add 9. You get x squared plus y minus 3. All of it squared is equal to 5. All right? So the center is 0, 3, and the radius is the square root of 5. Okay, when we're talking about ellipse tomorrow and a hyperbola, then we can work more on the interesting completing the score examples. All right, so we're going to write the equation of the circle with the center of 3, 5, but it passes through negative 1, negative 2. All right, so the center is 3, 5. This is hk. We can start by saying x minus 3, all of it squared, plus y minus 5, all of it squared, equals r squared. All right, now if I tell you that it passes through negative 1, negative 2, I'm giving you an x value and a y value. So I need to plug negative 1 in for x. I need to plug negative 2 in for y. Remember, anytime you square a number, it's always positive. So I get r squared is 65. And if I'm just writing the equation of the circle, that's all I care about. I don't need to know what the radius is. All right. So x minus 3, all of it squared, plus y minus 5, all of it squared is equal to 65. All right. Look at this one. Endpoints of diameter at 3, 6 and negative 1, 4. So the question is, find the equation of the circle with endpoints of a diameter at 3, 6 and negative 1, 4. So if you have endpoints of a diameter, that means the midpoint would be the center, right? So I drew the circle. I don't know, like here's roughly where 3, 6 could be. And then, doesn't really look like endpoints. We're gonna try this again. See if we can do a much better job. Endpoints of a diameter. So 3, 6, and then -1, 4. Okay, it's going like this. That's endpoint of a diameter. That means there's the center going through like that. All right? Anyway, let's find the center. Very rough drawing there. So in order to find the center, it's going to be the midpoint of these two. So we're going to take 3 plus a -1, divide it by 2. You get 1 for the x value. And then 6 plus, what's the middle of 6 and 4, folks? All right, that's 5. That's 5. So the center is 1, 5. All right? So x minus 1 squared plus y minus 5 squared is equal to r squared. And then it's just like the above question. I have choices, though. So it definitely passes through 3, 6, and it also passes through -1, 4. So I'm going to choose this one as an x and a y value. All right, 3 minus 1 squared plus 6 minus 5 squared is equal to r squared. 2 squared plus 1 squared is r squared. 5 is equal to r squared. X minus 1 squared plus y minus 5 squared is equal to 5. Cool. All right. Now, everyone pause. Please listen to these instructions well. I need for you to get out a separate sheet of paper, a clean sheet. Do not turn the following in on your notes. So if you need to pause this and get up and get paper, that is fine. Again, if you turn this in on a page that is notes, that has other examples on it, I'm going to deduct some points. All right? So on a clean sheet of paper to turn in without any issue this hour, to turn in, I don't know, just call it TRIG assignment, don't abbreviate assignment, TRIG assignment 512. Make sure your name is on it, okay? Again, on a separate sheet of paper, not on the back of a piece of paper you've written on a clean sheet of paper. In black, you have, we're just gonna write the equation of the circle. We're gonna find the center and the radius. So x squared minus 6x plus y squared plus 4y minus 16 equals 0. Let's write that out. Okay, let's complete the square. It's already in order. You just got to move the 16 over first. Okay. I asked myself, let's see, here's the middle term, -6. What's half of it? -3. What's -3 squared? 9. All right. So if I add 9 to the left, I'm going to add 9 to the right. Then I look at 4y. I take half of 4y, which is 2. I square 2, which is 4. If I add 4 to the left, I got to add 4 to the right. Add these together. That's 29. Then I factor. It's always half the middle term, so it's got to be x minus 3. What multiplies to 9 adds to a -6, -3 twice. Multiplies to 4 and adds to 4. 2 twice, because half of 4 is 2. All right, so the center is 3, -2, and the radius is root 29. The center is 3, -2, and the radius is root 29. Endpoints of a diameter, okay? Again, I'm going to write the equation of the circle with the endpoints of a diameter of that. All right, so again, we're going to, oh man, look at this one. This one's fun. All right, so I'm going to figure out my center, which is my midpoint. I'm going to add my x values together. What's in the middle of a half and 1 1/2? It's 1, all right? I add those two up. I get 2. 2 divided by 2 is 1. I take 4 for my y value. I take 4 plus -1, which is 3. 3 over 2 is 3 over 2. So my center is 1, 3 over 2. 1, 3 over 2. All right. X minus 1, all of it squared, plus y minus 3/2, all of it squared is equal to r squared. And then, you don't got great choices, so that's why I started this. I'm going to use that one. Here's my x value I'm going to plug in. There's my y value I'm going to plug in. All right. So I'm going to plug 1/2 in for x, minus 1 squared. And then I'm going to take 4. I'm going to plug it in for y. 4 minus 3/2, I'm going to square it, equals r squared. All right. -1/2 Yeah, it's just -1/2. If I square it, I get 1/4. 8 over 2 minus 3 over 2 is 5 over 2. 5 over 2 squared is 25 over 4. I add these two together, I get 26 over 4, which is 26 over 4, which is 13 over 2. You should simplify it for an equation. All right, now if I wanted to know what the center was, I would say, I didn't really ask that, but the center is 1 3/2, obviously. And what would you write as the radius? So if r squared is, this is a good one to use too, 26 over 4, you can call it root 26 over 2, which is what you would get if you said r squared is equal to 13 over 2. You'd have to call it root 13 over 2, root 13 over root 2, which is root 26 over 2. All right, anyway, you're gonna turn that in before you leave, okay? If you got some kids in class not watching, they've made their bed, folks. They've made their bed. Let them find out at the end. All right, turn this in at the end of the hour, because here's what I need you to fill in. So this is on your pre-calculus SIU final. This is number 4. Hopefully we did 1 through 3 last Wednesday and Thursday. All right, remember this is a 20-point grade. All right, so fill in the chart with exact values. Also include the radian measure. All right, so first off, 30 degrees, that's pi over 6. 45 degrees, that's pi over 4. And 60 degrees is pi thirds radians. All right, obviously you have calculators, but you want to know that sine of 30, which is sine of pi 6, is 1/2. You want to know that cosine 30, cosine pi over 6 is root 3 over 2. You want to know that tangent is sine over cosine. 1/2 over root 3 over 2 is 1 over root 3, which is root 3 over 3. Some of your calculators can tell you that, but again, you want to have that down, folks. That shouldn't be too tough. Sine of 45, or sine pi fourths, root 2 over 2. Cosine of 45, cosine pi fourths, root 2 over 2. And then what's tangent? Well, it's 1. It's root 2 over 2 over root 2 over 2. And sine of 60, or sine of pi thirds, is root 3 over 2. Cosine of 60, or cosine of pi thirds, 1/2. And then tangent is sine over cosine. That's going to give you root 3. Okay, so we're going to pause there. I'm going to say this is done for 5:12. All right, it's going to be Yak Math Videos signing out.